All right, we're back with some more Palantir interview prep, and today we're doing leak code 136, single number, and we're given a non-empty array of integer nums, and every element appears twice except for one, and our goal is to find that single one that does not appear twice. The key distinction about this is that we have to have a linear runtime and only constant extra space. So we can't have a set or a dictionary to track the occurrences because of that. So um, it's going to be a little more difficult than you would initially think. So our solution has to have a linear runtime, like I said. So these are examples. Nums has 221, and 1 is the only one that occurs once. 4, 1, 2, 1, 2. 4 only appears once, and then our base case is just one element, and the output is that one element. And so my initial thought, well, this code, I'm kind of surprised. This actually passed the test, so maybe they need to improve their tests. But I essentially my first solution was to essentially pop each element of the list, and this wouldn't work if the list was immutable, and essentially see if that value we popped is in the list, we remove the other occurrence of it. However, list.remove in Python only removes one other occurrence of that value. So if there's duplicate, let's say there's 3 of that occurrence, then this wouldn't work. On top of that, it is kind of slower and less efficient. But it passed. I think it beat like less than a percent of cases. So, and I believe it runs an O event time. So this is my first solution. I think this problem's a little stupid just because it expects you to use XOR to essentially determine whether it's in the list or not. The way it does it is that if you do XOR on number of itself, then if you do the bitwise operand on itself, then it just returns 0. So like, let's say we had 0, which is just like, I don't know, 1,000, right? As in bits. So 1,000, 1,000, XOR, exclusive OR, 1,000 equals 1,000. So it just goes to 0. So we just do that. We traverse the list and we return it like this. It beats 100% of cases. It's kind of ridiculous that they're asking this because I feel like this is no one's first thought, but it wasn't too bad of a problem, and we got it after the hint down here.